Good morning. I'm Jyoti Kumar. Today we'll discuss about the topic critical section problem. Here, what is a critical section problem? Each process has a critical section, a segment of code. The process may be changing common variables, updating tables, writing files, and so on. When one process is in the critical section, no other may be enters in its critical section. Assume we have a two process and each and every process has its own critical section. If one process enters into the critical section, the other process will not enter in its critical section. If one process enters in the critical section, meaning that it is capable of handling, it is capable of editing the data which is present in the shared variable. Shared memory. What are the things that it may change? One is a common variable, updating the tables or writing of files that will happen in the shared memory. So similarly, for the other process, if one process is in the critical section, the other process will not enter into the critical section. If that process also enters into the critical section, then again that process is also will edit the data, common variables, updating tables, and writing files in the shared variable. And that should not happen, so that if one process enters into the critical section, the other process will not enter into the critical section. This is actually called as a critical section. Critical section problem is a designed protocol to solve. Each process must ask a permission to enter in its critical section. In each entry session may follow the critical section with the exit section and then remainder section. This is a structure. Here I have a do and then entry session. The process is requesting a permission to enter in its critical session. The permission request will handled by the entry session. Once the permission was accepted, then the process enters into the critical session. And then after critical session, it is moved to the exit section. And then we have a remainder section in the particular program. And then while of true. Here, if the process is requesting a permission to enter into the critical session, assume as I said, we have two process. Okay, this is I just represent here. Here is a process I. If we have a process one or process two, if this assuming it as a process one, the process requesting for a critical session, and the entry session allow the particular process to enter into the critical session, meaning that the process 2 is not entered in its critical session. If the process 2 is entered in its critical session, then the process 1 will not allow to enter in its critical session. This is called as a critical session problem. Here is a simple representation of the algorithm. While a turn of j which is equal to j, and then it is a critical section, and then a turn which is equal to j, and then move for the remainder section and while of true. If this is not true, then the process enters into a critical section. If this is said to be true, then it is moved to the remainder section. Coming to the solution for the critical section problem, it's a mutual exclusion. As I said, we have a two process 1 and process 2. If one process enters into the critical section, the other process will not enter into the critical section. Simply, it mutually excludes the another process to enter into the critical section. We can term it as a mutual exclusion. Coming to the progress, if no process is existing in its critical section, and there exists some process that wish to enter into the critical section. If none of the processes is in the critical section, and we have some process which is wish to enter into the critical section, we have a number of processes which is ready to enter into the critical section. Then the process which does not have a remainder session will have to decide which process will enter into its critical session. This is the concept of progress. The process which does not have any remainder session, then that process will choose which process have to enter in its critical session. That is called as a progress here. Coming to the bounded weight. The bound must exist on the number of times that the other process allowed to enter into the critical session. This is the concept. If we have a certain set of a bound, or we have certain set of limit to a particular process that are allowed to enter in its critical session, after a process that has made a request to enter into its critical session, or before that the request is granted. That's all about critical session. Thank you.